Okay, this is question 2013, question 2, FRQ, AB. So a particle moving in a straight line from 0 to 5, and here's the velocity function. The position is s of t, and s of 0 is 10. So they're saying at time 0, you are at 10. Now this particle, if you think about it, doesn't say which direction it's going. It could be going up and down. It could be going side to side. But think of it as a car, you walking in a straight line, whatever it is, you or this thing, they call it a particle, is going directional back and forth or up and down. Again, a lot of times they'll tell you what direction it is. This one did not. And this is the function for velocity. So the first question, find all values of t. So we're looking for time from 2 to 4. Oh, wait, that was 0 to 5. Okay, but they said 2 to 4. So they're changing the interval on you. But it wants the speed is 2. Be careful, that's the speed is 2. They don't want the speed at 2. They want the time at which the speed is 2. Now, something you might need to be aware of, the speed function. Do you understand speed is velocity without direction? If you had a velocimeter, sounds like a dinosaur, but if you had a velocimeter on your car, it would have directions on it. It'd be like a compass on a, yeah, it'd be all confusing. A speed is a non-directional velocity. So you don't need, so how do we get rid of negatives? How do you get rid of direction? Absolute value. So for A, well, speed is the absolute value of velocity. That is speed. And I want to know where it is 2. So aren't I looking for when that is 2? And this is a calculator-based problem. So could you graph this? Could you graph 2 and see where they cross on this interval? Do you got the interval is important? So you adjust your window from 2 to 4, and you see where this function, not this one, it's the absolute value of that one, intersects the graph of 2. Do the math crunch on your calculator. It is a very mathy. And what you will come up with is the answer of, if you do it, you will get a time of 3.128 and 3.473. Now, I just popped up those answers, but you would use your calculator to get those. Those would be the two. Now, if you did it from 0 to 5, you're actually going to get more than that. Got it? You got to read your directions. It only wants 2 to 4. All right. Write an expression involving integral. So I bet there's going to be an integral going on here. Gives a position. So S of t. Use the expression to find the position at 5. So make sure you answer both questions. You're making an equation, and then you're going to plug 5 in right there, aren't you? Isn't that what it's saying? Once you make the equation, aren't you then finding S of 5? So let's make an equation. So problem B. A position function is S of t. Does a position, don't we have to find out where we start to find out a position function, where we're located? You always got to know where you start. So don't we start at S of 0? Because according to the problem, isn't S of 0 given up here? Which, won't that S of 0 be 10? So we start at S of 0, and then aren't we summing from there change from 0 to some value? Aren't you going to sum change? And because we're given velocity. Isn't velocity change? Velocity is an integral. It's change. So if I'm summing change, I want my velocity function here. When I integrate velocity, I'm going to get position change, amount of change. So what I'm going to put here is v of, I cannot put t, I'm going to put v of x. Can you understand why I cannot put t? Because isn't that a t right there? So doesn't t have to be plugged in later on? So I need a different variable. Could you choose any letter there? Yeah, x is just, you could put y, you could put smiley face, theta, you can put anything you want. I mean, x is just nice. But if you put t's in both, you'd be marked some points off. So that is your function. Initial position plus your change in position. If you want to know where someone's located, don't you know where they started and how much they've changed from that point? Especially if they're going forward and backward on a line. And then you know where they're at. Okay, that's only half the question. What's the second part? The second part is find at 5. Okay. What's S of 0? Wasn't that 10?
Yeah.
Plus, are we going 0 to 5? Isn't that the number we're plugging in for t? Of v of x dx. So you might be like, okay, how do I do this? Don't you have a calculator? Don't you have the function right here? Could you just use your calculator to crunch this? Add 10, you're done? You just got to be good with your calculator. And once you do all that, your answer is going to be negative 9.207 is your answer. By the way, we probably should have circled this one up here, or boxed. You always want to box or circle your answers, because it's kind of important. So what does that mean? If I started at 10, I ended at 5 seconds at a negative 9.287. I ended 19 points away from this in the other direction. Did you catch that? If I started at 10, I ended up at 19 values in the other direction on a number line. Because 10 back to 0 and 9.207 farther. But that's your position now. Now, could you find your position anytime from 0 to 5? Now, the function gives you 0 to 5, so you can find it 1, 2, whatever you want. Plug the number in there, you're good to go. And you can find any position you want. Next problem, C. Find all times on the interval 0 to 5, so we're back to the 0 to 5, for which the particle changes directions. Justify your answers. Okay, it's the first time we had to justify. So change directions. So we're changing directions. And be aware, justifying, in the back of our minds, let's keep justifying our heads. We'll get to that, but let's find out where it changes directions. Doesn't it change directions when the velocity changes sign? If you're walking one way, if I'm going this way, isn't my velocity positive?
Yes.
Now is it negative?
Yes.
Now is it positive? So the first step, besides being, let's just start off with that. C is where the velocity changes sign. Would this be an important statement for my justify? Would that be part of my justify at some point?
Yeah.
So if I state that, I have that started, and you're going to need that in your brain for when you do this. But before I kind of find out where it changes signs, where does it change signs? What does this velocity equal when it changes signs? What is the velocity function going to equal when it might change signs?
0.
It equals 0, or what else? Does not exist. Do you understand? At zeros and does not exist, could it change signs? At zeros and undefines, those are two possibilities. So what we're looking for are these, and then once I find these, are we looking for making sure the blue happens? And then we are done with this question, and we just got to justify. We have part of our justify already here. My reasons are right here. We just got to kind of piece it together for the justify. So how do we find where v of t equals 0? Well, can't you just graph that? Look at your graph from 0 to 5 and look at where it crosses the 0 and use your 0 function. There's a 0 function on your calculator. You could totally just look at your graph, find the 0 function, done. Or undefines. You kind of got to look at your question, see if there's undefines. I don't think there are any, so you probably don't have to worry about that. You're just looking for zeros. So you look for those. And you look, okay, where all does it happen? And there are several spots where it happens. When you do this, it's going to be at these times. So here's the times at which this is going to happen. You have it at 0.5360 33, I hope I wrote that down right, and at 3.317756. Now, why did I put so many numbers? Because it's intermediate value. Okay, for now. We'll just put it, just to be careful. That's where it equals 0. Now, which one does it change signs? Well, could you just look at your graph and see? changing signs doesn't mean where it actually crosses the x-axis. So does it cross the x-axis at both of these? And if we look at the graph, you will notice at both of them, it will actually cross the x-axis. So this statement, a changing signs, will happen at both those. So my answer is both of these. Now, could you do more than 3 decimals? Yeah. You can just leave it. There's your answer. Did I answer what I wanted? All times. Are those the 2 times? Now, justify. That's not good enough justify. This hidden here, partial justifying. I'm not going to write it all out, but do you understand your justify should be maybe a sentence or two saying, okay, my velocity is 0 here. And then you got, okay, my velocity is negative here. My velocity is positive here. Thus, it's going to be at these 2 points, the velocity changes signs. Look at my information that shows it. You need look at your FRQs. You'll see how to word it, but you need more wording. Justifies are my last thing I go to because sometimes they're kind of wordy and it takes a little bit longer. I like to get the answers first. Just don't forget to justify. Next problem, last one. The speed of the particle increasing or decreasing at t equals 4. Give reasons. So we're going to need to give reasons, so be careful. Now this is important. Speed, increasing, decreasing. Now, the FRQ scoring guidelines does it different than I do. Watch what I do. Speed. Isn't this speed? And if I want speed increasing or decreasing at 4, okay, isn't it asking for the derivative of speed at 4? Isn't that what it's saying? Isn't increasing mean derivative? Isn't decreasing mean derivative? It's just asking for, is it negative or positive? Isn't that what it's saying in that? So if I just take the derivative of the velocity graph at 4, and if my answer is negative, what's my answer? Isn't it? If my answer is negative, won't that be decreasing? If my answer is positive, won't that be increasing? I'm done. So we look what would happen here. And if you were to do that, if you were to graph this function without the 4 in it, if I graph the speed function, and at 4, if I found the slope of it there, if I found the slope at 4, can you just look at it and see if it's up or down? If you graph this derivative, the derivative of g of absolute value, g of t, and looked at it, isn't it saying the slope at 4? It's saying the slope of the absolute value graph at 4. So if you looked at the graph, absolute value graph, and thought, what's the slope? Or there are different ways of looking at it. But in the end, this is what you're asking for. And the answer is it's increasing. So what that means is your answer would have been positive. So my answer is increasing. All right? So it is increasing. And my reason why is this. Because this is speed. I have to write that. This is my speed function. And my derivative of it at 4 is positive. So thus it's increasing, not decreasing. I am done with that problem. Now, let me show you other ways. If you were to look at the graph of the velocity, I'm not going to draw the actual graph of velocity. I'm going to make one up. Just watch for a second. Let's say that was my velocity function. What would my speed function look like? Let's call this velocity. What would speed look like? Well, wouldn't it take this graph and flip it over? Wouldn't that be speed? Not position, but speed. If velocity is a red, wouldn't the blue be speed? So let's say I choose a dot right here. Is the speed and the velocity the same? Are they both decreasing? At that point, aren't both the speed and the velocity both decreasing? But watch this. What if I chose at this point right here? Well, depending on what you're talking about, aren't they doing different things? What's the velocity doing? Isn't the velocity decreasing right there? But what's the speed doing? Increasing. Oh, wait a second. Okay, I'm bad at that dot. Almost looks like it's 0. I'm sorry. But at that dot, isn't the speed increasing, but the velocity is decreasing? That's weird. And this is how you could justify it. If you drew the sketch, you can show, oh, the velocity looks like this, and that is going uphill. Because the velocity gets flipped. Over here, if I had a dot right here, let's say right here, boom. And don't you have those two dots possible? So whatever this value is, the speed is decreasing, but the velocity is increasing. It's kind of tricky. And if you look at the scoring guidelines, they do it a whole weird way. It's interesting. It works, but I like thinking this way. Good luck on the question.